Okay, so in this video we're going to set up our second class, or our third class I should say, and make sure that we can start using our high score class. So again, we're going to follow the same procedure. We're going to select the source folder, we're going to right click, we're going to say new class. In this case I'm going to call it scoreboard. We use mixed case to name our classes, and we hit finish. And it's the same basic setup. We have a basic class, we have nothing special, but we need the same four pieces. First thing we need is our data, and then we need our constructor, and then we need our getters and setters, and then we need our, now of course when you're documenting, you document it much more cleanly than this. This is just a demonstration. And then we need our functionality. Now what I do need to mention about documentation, if you are using object-oriented classes and whatnot, every individual class needs its own header. That's why that file name part of the header exists. Okay, so every different piece needs its own header. So let's go through this and look at our scoreboard. Now looking at our design here, our scoreboard is made up of two main variables, max scores and scores. Now we might want to actually keep track of another variable called like num scores, which keeps track of how many scores we actually have in the scoreboard. This could actually be pretty useful when it goes into things like displaying or sorting and everything like that. So we're going to create three variables. First one, int max scores. I don't know what that is yet. Next thing we're going to have is int num scores. And the next piece is we're actually going to create a container to hold our high scores. We're going to create an array that's going to hold a whole collection of high scores. So its data type is going to be high score because that's what we called our class. It's going to be an array, and I'm just going to call this scores. Now you'll notice that I'm not finishing it at this point. I'm not saying equals new high score, let's say 10 or something like that. And the reason why I'm not doing that is because I don't know how many scores are going to be in this high scoreboard yet. That's what max scores is. So I can't actually define its size. But I can say, hey, guess what? I'm going to be creating a container to hold high scores. So just make sure you're ready. So that's the basics for this. So now that you know what a constructor is, we're going to get right into that before we get into the getters and setters. Oh, I guess I should set up our private and public, our access modifiers. So max scores, we're going to set that to private. Num scores, we could set this to private or public. If we set it to public though, that means it gives the external classes the ability to change this, and that's not good, because let's say the main class, which is going to have an instance of scoreboard, accidentally sets num scores to 0 even though that there's 5 in there. That means that you don't have access. You don't even know that those other ones exist anymore. So that is actually a problem. So we got to be careful about that. Same with max scores. We don't want anything manipulating these things prematurely. It's like when you walk into a bank. Your money is in the vault. That is your money. But you're not allowed to walk into the vault and just get it. You have to go up to the teller. You got to go to a bank machine. You say, please withdraw $200. And then either the teller or the bank machine first verifies that you have $200 in your bank. So think of this like the getter. It's saying, do you have the data to be gotten? If you do, then that teller or the machine will go retrieve that cash for you and then hand it over to you. But only once you've been given the approval to do so. So this is what private and public really comes into play. So you know you have data, but that doesn't mean you have access to actually do anything about that data. That's why vaults exist. That's why we go in there and we have that protection. So nobody can just walk in and say, hey, I want that dude's money. You can't work like that. So we have these protection mechanisms, and it's for everybody's own good. So we're going to make all three of these private. More often than not, you want your data to be private. Very rarely is your data going to be public. It just creates bad situations where you might accidentally modify something you shouldn't be modifying. So now in our constructor, we're going to create our constructor, again, public, and it's the same name as our class, scoreboard. Now the question is, which of this data is going to be required to create our scoreboard object? Well, max scores for sure. I need to know how many max scores. So int, let's say, I don't know how to write this. Let's say new max scores. Just keep it simple. I'm trying to use unique variable names here. Do I need a variable for num scores? No, I don't. I know that there are 0 scores in there at this time, so I do not need that information. So I can actually just say, I just need to go right directly into, well, that's it. I don't even need to create anything else for the scores variable. That's it. I'm done. That's all that's needed to create one instance of the class. So now I need to set up that data. I need to set max scores. So max scores is equal to new max scores. Great. Now I need to finish defining a whole bunch of things. First of all, how many scores do I have to start out with? Well, I have 0. I don't have any scores in the scoreboard yet. So I can just manually set this to 0. The next thing I need to specify, did I spell something wrong there? Why does that give me an error? Max scores. The next thing I need to specify is how big my scores array is. That's where max scores is going to come into play. So I'm going to say scores is equal to a new high score array of size max scores. So now it's actually the size that we want it to be. Now that being said, there's no scores in there, so I have to be careful about this. I have to be knowledgeable. So whenever I'm using a for loop or whatever to go through my array of scores, I'm not using the max scores as my ending variable. I'm using num scores. Make sure I don't go past the number of actual scores in there. So our getters and setters, what data are we going to be getting? What data are we going to be setting? I don't want to give them the ability to set max scores. I don't want to give them the ability to set num scores. And I don't want them to give them the ability to set scores. So there's not going to be any getters. And in fact, they're not going to be able to set max scores because that would change things. They're not going to be able to set num scores. That'll change things. That's a problem. And they're not going to be able to change the high score array directly. So they are not going to have any getters or setters. So in this case, none. We're not given any external access to this at all. Not happening. But we do want certain functionality. We want to be able to display the scoreboard. We want to be able to insert new scores. We want to be able to say get the maximum score of the whole setup. So let's go through a few of these, and I'm going to leave one of them intentionally blank because I want you to do that work. But I'm going to create a series of 5 subprograms, and then we're going to fill them out in a second. So the first thing we're going to have is a variable or a function called get max score. So let's say public. We want this to be public. Get max score. It's going to be returning an integer. Int get max score. Max means maximum, the biggest score. Doesn't have any parameters. And we'll go into what this is going to be in a second. I'm not going to fill this out right now. Right now it's giving me an error saying, hey, you're promising me an integer, but you haven't given me a return value that's an integer yet. So for now, just for temporary placeholder purposes, I'm just going to say return 0. We're going to flesh that out in a bit. I just don't want it to have a bug right now. Next thing, we're going to have another one called public void display scores. This one is going to go through all the scores and cleanly and neatly display them on the screen using that handy dandy get output string function that we set up inside of high score. Again, we're just going to leave that blank for now. We'll flesh it out in a minute. And then we have a few more that are very important. First thing we're going to have is a public boolean, and we're going to call this one is score eligible, and new score. So basically this says look at the lowest score in the scoreboard. Is the new score better than that one? If so, yes, it's eligible, return true. We're not going to flesh this out just yet. We'll come back to that in a minute. So we're just going to say return false. Okay, 2 more. So if it is eligible, we want to be able to add the new score in. Now we know that it's eligible, so we know it's better than at least one of the scores. So what add score is going to do, it's just going to insert it at the very end. It's just going to overwrite the last score in the array. because we don't need it anymore. It's gone. It's not as good as this one. So we're just going to overwrite that last one. It's the last place score, so now this is going to be technically or temporarily the last place score, but not really. So we're going to say public void add score, and this is going to add in the new score. Now, of course, a score is actually comprised of a name and a string, or sorry, a name and an integer. So this add score is actually going to create a new high score object and then insert that high score object into the high score array. But again, we'll flesh that out in a minute. String name and int, oh, let's say new name, sorry, string new name and int new score. We don't need to, we can just call it name and score. Name and int score. And we'll flesh that out in just a moment. And lastly but not least, the one I'm not going to fill in for you, now this one I'm going to make private. Private void sort scores. What this one is going to do is it's going to look at the scores array and it's going to reorganize it to make sure that the best score is at the top at element 0 and the worst score is at the bottom at whatever num scores is. And then all the other scores are left blank. And why do we do this? Well, or why is it private? It's private because the external classes don't need to manually call the sort. Every time we call add score is then going to call sort scores, so it resorts itself after a new score has been added. So a pretty simple process. So let's start fleshing this stuff out. For every one of these, basically, well, for almost all of them, we're going to need a for loop. And that for loop is going to go through all of our scores that are currently in the array and check or manipulate that data in some way. So for get max score, we need to know what the best score is. So this is actually a pretty simple process. We know because our high score set score functionality is manually forces the score to be at least 0, that it must be a positive number. So what I'm going to do is I'm going to create a variable called int max score, which has a value of -1. I know that at least one of the scores inside of here is going to be better than that. However, if there's no scores in there, then it's just going to return the -1, which means there is no possible good score here. So here, now we need to go through every score for int I is equal to 0, such that I is less than, not max scores, num scores, however many are currently inside the array. I++. Now you're going to need to memorize this for loop because you're going to use it in almost every one of these. Actually, you are going to use it in every one of these functions. Maybe not add score. So now I need to say, hey, is the current score of the current high score better than max score? If it is, reassign max score. So if what's the variable? Our variable is called scores at I. So the current score that I'm looking at is now what value? Now this is how we access the public data. Now this is where everything gets really interesting. Whenever we want to access anything public of an object, all we have to do is use the dot operator. And anything public that we can access will be in this list. So in this case, we want to get the score. So I want to get score, and if that score is greater than max score, that means this is a better score. So I'm going to set max score equal to scores at I dot get score. Oops. I don't do anything in the else case. I'm not going to touch it. I'm just going to leave it alone. Well, that's it. So once it's done going through the entire list of valid scores, it's going to have the maximum score possible, because every time it's checking to see whether the next one is better. If it is, replace it. And instead of returning 0, we're going to return max score. So our post condition of this will say returns the maximum score if there are scores, otherwise return a -1. That way the programmer knows to handle that -1 just in case. Display scores. Well, we're just going to use this for loop. We're going to go through every score. And for every score, we're going to call that high score functionality that we set up. Get output string. System.out.println. Oops. My goodness. The current high score, so scores at I dot get output string. That's it. That's all we have to do display scores. This little dot operator means ownership, right? So whatever is owned by the current high score. Scores at I. Why I? Because I goes from 0 all the way up to the total number of scores. Alright. Is score eligible? Well, this one, we know that the score is eligible if the current new score is better than the old last place score. And we know because our scores are sorted that the last place score is stored at num scores, that element. So basically this one is not a for loop, we just need an if statement that says if scores at num scores. So let's say we got to be careful about this. So let's say there's no scores currently added to the scores array. That means that num scores has a value of 0, but that's a valid number. So we actually have to modify this. It's if scores at num scores minus 1. Minus 1. My goodness, minus 1. If that value is greater than, less than new score, then that means that it is eligible because the current last place score is less than the new score. So we need to return true. Otherwise, we return false. I don't need an else case, and the reason why I don't need an else case is because if it gets in here, we'll automatically go here and then just get out. However, oops, this should be .get high score. Why is that not coming up? Scores at num scores. There it is. Good score. So if the last element score is less than the new score, return true. Otherwise, return false. So that is score eligible. All add score is going to do is put the new score at this element. It's going to replace the last place score. Okay. Now, of course, this comes with a bit of a caveat. You only do that if the score array is full. If the score array is not full, then you just put it at the next element, the one more than num scores. So we know that the score array is full if num scores is equal to max scores. So if that's the case, then we just overwrite the last element. Otherwise, we just put it in the next element and increase the number of scores. So it's a two-tester. We need to check both sides. So we say, okay, if num scores is equal to max scores, that means that the list is full. Then we just want to insert it at the last element. So we just say scores. First thing we need to do is create a new high score. So high score, new score, is equal to new high score. So this is how you create one instance of an object, one instance of a class. You have to use this new keyword. What this is doing is this is calling the constructor. And now we need to specify all the data from the constructor of high score. In this case, and in the correct order. Score followed by name. So, well, score, which is right here. We're just using the parameters that were given to us. Followed by name. And that creates the high score. Great. Now, if the list is full, then we need to overwrite the last place score with this new score. So we're going to say, okay, scores at num scores minus 1, because it is the last one. Num scores would actually give us one too far. we are going to assign that equal to new score. The one that was there is now magically gone. It's just gone. However, if the list is not full, all we have to do is insert it at one past the current full point. So, which is actually the value of num scores, in theory. So if if there's currently no scores in the list, num scores has a value of 0. So if we insert it at num scores, that means the first element gets the new score. So we just say scores at num scores is equal to new score. But now, because we added a new score, we need to add one to num scores. Oops. So we've now added our element. Now what sort score will do is it will actually go through this list and start manipulating it. In the next video, this video has gotten really long, a lot longer than I wanted it to, but in the next video we're actually going to tie all this together and make the program work.